Um, Hello, everyone. Um, I just wanted to post a couple of slides on lung function. Uh, you can use these study questions to help you study for your next week, next quiz, or probably sometime next Thursday or Sunday. I will let you know. So these are the questions that I want you to take a look at. So the first question is identify the structures and functions of tissues that are included under the upper and lower respiratory tract. So both upper and lower respiratory tract have their own divisions. So I want you to identify each of the structures that fall under each category and then try to understand what are the functions of each of these tissues. The second question is how is the trachea organized and how are the lungs organized? In your slides, there is a picture of both the lungs and the trachea, and I just want you to take a look at how air gets into the lungs and just identify the parts of the trachea. And the third one is, can you explain the different types of volume measurements of the lung function? This one I'm gonna go over it. I have one picture to share with you, so I will go over this one, but I want you to understand each of the different types of volume measurements. And the first one is to identify the difference between obstructive and restrictive disorders of the respiratory system. And I want you to go over the examples for each kind of disorder. And the last one is about breathing mechanism. Here I want you to closely check how the muscles and the diaphragm react during inhalation and exhalation. How do the muscles respond? How does the diaphragm, what happens to the diaphragm? What happens to the muscles of the ribs when you are inhaling and exhaling? So for the lung volumes, um, so this thing was good. I have to share screen. So, okay, the respiratory system. Right. I think you can see this one now. This one is better. So lung volumes. Let's start from the smaller wave-like structures. As you can see on the y-axis, there's lung volume, and as you see, it goes from 0 to 6,000. It is measured in milliliters, so we are looking at 1 liter, 2 liter, up to 6 liters. So this one is normal breathing. So let's say when you are inhaling, the amount of air in your lungs is going to increase. So inhale, exhale, inhale, exhale, inhale. See, when you are inhaling, the blood volume is going to increase. Exhale, and then you are going to take a deep inhale as much as you could. And then that's the maximum amount of air that you can breathe in, and then you exhale back again. And then inhale, exhale, inhale, exhale, inhale, and then you are gonna exhale as much as you could. That means you breathe out all the air you could. And this is the minimum. So you cannot breathe out at this point. And then you inhale back again and then you exhale. So right here, the amount of air that you inhale and exhale during any regular time is called tidal volume. This is just the amount of air you breathe in or you breathe out at this moment. Not together, just either the amount of air you breathe out or the amount of air you breathe in. Then let's say you breathe in as much as you could, and the amount of air that you breathe in is at its max. So this is called inspiratory reserve volume. How much more volume of air can you breathe in after your regular inhalation? You inhale, and then you try to inhale more. And the amount of air that you breathe in after your regular inhalation is called inspiratory reserve volume. That together, including the tidal volume, we call it inspiratory capacity. Inspiratory reserve volume plus tidal volume. Okay, that means you exhale normally and then you try to breathe in as much as you could. And this whole height from here to here, we call it inspiratory capacity. Now, you exhale normally and then you inhale, and then again you try to exhale as much as you could to reduce the amount of the volume of air in the lungs. So you go as much as you could, and this is called the expiratory reserve volume. How much more can you exhale after your regular exhalation? This is called expiratory reserve volume. Now, at a certain point, after you breathe out as much as you could, still there will be some amount of air that's going to remain in the lungs, and that's called residual volume. And this residual volume, which is around 1000 milliliter or 1 liter, is always going to be here. Together, the expiratory reserve volume plus the residual volume, we call them functional residual capacity. Now, look at the colors. We have dark gray, and we have pinkish, and we have light bluish color, and then we have a regular gray color. So as you can see, the dark gray is the inspiratory reserve volume, and the pinkish color is the tidal volume, and the light blue color is the expiratory reserve volume, and the regular gray color or the light gray is residual volume. Now, vital capacity includes everything except the last one, except the residual volume. That means this is something you can actually do. You can inhale as much as you could or exhale as much as you could. So those boundaries are the boundaries for vital capacity. You inhale as much as you can, and then you exhale as much as you can. That's telling you the vital capacity. So to know the amount of vital capacity, all you have to do is just first you breathe out as much as you could. You are at this point now, after you breathe out as much as you could, and then you inhale as much as your lungs could carry. That's vital capacity. Total lung capacity is everything that your lung could carry. That means vital capacity plus the residual volume is going to give you the total lung capacity. That's all about the lung capacity.